Yeah, good evening everybody. Let us discuss about the JEE mains and January 22nd evening session paper. Here, as per the memory, we have collected the questions and let us go for these questions here. In this, the first one is an assertion and reason type. It is from the gravitation and simple harmonic motion, a simple one. Here the question, the assertion is given as a simple pendulum is taken on a planet of mass 4 times the earth and 2 times the radius of the earth. That is, it is a planet and mass of the planet is 4 times to mass of earth and radius of the planet is 2 times to radius of earth. And simple pendulum is taken on that planet from earth. When simple pendulum is taken from earth to that planet, the assertion given is time period of the pendulum remains constant. Here, the time period of the simple pendulum is 2 pi under root of length of the simple pendulum divided by acceleration due to gravity. If it is on the earth, the acceleration due to gravity near to surface of earth is gm divided by earth radius r square. Whereas, if you go for on the planet, the gravitational acceleration due to gravity g dash will be g, and mass of the planet is 4 times to mass of earth and radius of the planet is 2 times to radius of earth. So g m by r square. This is same as that on earth surface. So g remains the same, length of the pendulum is not varying, then time period remains same, then assertion is a correct statement. Let me go for reason. The reason is time period of simple pendulum is constant on earth and on any other planet. Here time period of the simple pendulum is constant on earth. We can't say because this time period of the simple pendulum 2 pi under root of L by G, here G can vary depending on rotation of earth and latitude, altitude, and he given the statement that time period remains constant for simple pendulum on earth and any other planet. That's not possible depending on the planet. When G varies or when length of the pendulum varies, it varies. So second statement is incorrect. So assertion is correct, reason is false. Let us go to the next question. This is taken from geometrical optics. Here a thin biconvex lens. So it is a thin lens, biconvex, both sides are convex and is divided into 4 equal parts as shown in diagram. The 4 equal parts is like this. One along the principal axis and another along the optical center. It is made into 4 equal parts. So in this case, original power of the lens is 4 diameter. And the question is, find the power after dividing. Find the power of each piece. Here, when you divide the lens like this along the principal axis, if the 2 surfaces will have radii of curvature, if suppose radii of curvature of both surfaces are same, here radii of curvature remains same, so focal length doesn't vary, and focal power of the lens in air is 1 by f, so focal power doesn't vary. Whereas again when we made this into next part, if I take one of the part, here this is a plane surface, so its radius of curvature is infinity and this is having radius of curvature r. Now let me calculate the focal power. Here in first case focal power is 1 over focal length of the lens, that is lens material refractive index mu minus 1 into, according to sign convention, 1 by r minus of minus 1 by r, that is 2 by r. So focal power in the first case will be 2 into mu minus 1 by r. Whereas in second case the focal power is 1 over focal length in second case, that is mu minus 1 into one surface has radius of curvature r and another surface radius of curvature is infinity. From geometric sign convention, 1 by r1 minus of minus 1 by r2 is plus. So this term is 0. So mu minus 1 by r So in second case, the focal power is mu minus 1 by r. Here, this first case focal power is given as 4 diopter. Then in second case, it will be half of the first case. So this will be 2 diopter. So this is the answer. Let us go for the next question. In the next one, it is from fluid dynamics. There he given a tube of flow like this, and radius of the tube decreases from 2r to r. So here radius is 2r, here radius is r, and fluid is entering the tube and leaving the tube. Here the speed at one end is given as 2 meters per second at this end, and he asked speed of the water or speed of the liquid at the other. Here it is incompressible and irrotational if it is non-viscous, if it is flowing steadily. We can go for equation of continuity from area into velocity everywhere same. So A1 V1 equals to A2 V2. Here radius is 2r, it is cross sectionally circular. So area will be pi into 2r whole square, and here velocity is 2 meters per second. In second case, radius is only r square, velocity v2. So pi we can cancel and r square balances. Here 4 2s are 8. So v2 is equals to 8 meters per second. And this is about this question. Let me go for the next one. It is from the electromagnetism and Biot-Savart law. In this case, there is a large wire, straight wire carrying electric current 8 ampere. Another large straight wire parallel to this carrying electric current in opposite direction, and the current is 4 ampere. The distance between these two wires given is 6 centimeter, whereas there is a point P, and the distance from point P to this first wire is 4 centimeter. Now the question is, find the net magnetic field intensity at point P, that is magnetic field induction strength. And due to this first wire, the magnetic field will be inside. Due to second wire, magnetic field will be outside. So when both vectors are in opposite direction, we can say that the net magnetic field intensity will be, due to this wire, if I imagine B1 outside, and due to second wire is B2. So let me go for calculation of the magnitude. Here, due to large wire, the magnetic field intensity will be, as we know, mu naught I divided by 2 pi into distance from the wire, r. Mu naught is 4 pi into 10 power minus 7. So 4 pi by 2 pi is 2. So 2 into 10 power minus 7 multiplied by current divided by resistance. According to this condition, if you calculate the magnetic field there, B1 will be here, if you go for this wire, current is 4 ampere, distance is 4 centimeter. So 2 into 10 power minus 7 mu naught by 2 pi into current is 4 ampere by r, the distance is 4 centimeter, that is 4 into 10 power minus 2 meter. Here this is 4 we can balance, and 2, let me go for, this is 2 multiplied by 10 power minus 7 minus half minus 2. So 10 power minus 5 due to first one. Due to second one, if we go, mu naught by 2 pi is 2 into 10 power minus 7, and current in the second wire is 8 ampere, and the distance from second wire to point P is 10 centimeter. So current is 8 ampere and the distance is 10 centimeter. So current is 8 ampere, distance is 10 centimeter is 10 power minus 2 meter, and we can go like 2 5s are 10. So here 5 1s are 8 minus 5 is 3, 1.6. So this is 1.6 into 10 power minus 5. Here we are having magnetic field due to first wire as B1, due to second wire as B2. Both vectors are in opposite direction. So net magnetic field will be B1 minus B2, that is why 2 minus 1.6, that is 0.4 into 10 power minus 5. We can write it as 4 microtesla. Next go for fixed question. Here for a non-vibrating diatomic gas, adiabatic constant is gamma 1. So gamma 1 is adiabatic constant for non-vibrating. So non-vibrating means only translatory motion kinetic energies and rotation kinetic energies exist. Whereas gamma 2 is the adiabatic constant for diatomic gas. In both the cases it is diatomic and it is vibrating diatomic gas. Vibrating, I mean it will have translational kinetic energies, rotational kinetic energies and kinetic and potential energies due to vibration. That is why number of degrees of freedom of the gas in second case will be more than in first case. Whereas relation between gamma and number of degrees of freedom are gamma equal to 1 plus 2 by F. When F is more in second case, then gamma will be less in second case. So gamma 2 is less than gamma 1. We can write this as gamma 1 is greater than gamma 2. So this is about the question. And let us go to next one. For the next question, it is from rotational dynamics, a simple concept and easy one. Here in this question, he asked that a force F is equal to 2I plus J plus 2K. He is acting on a point P. He is acting on the point P and that point P is lying at origin. And he is asking the torque about a point 1, 1, 1. So we have to calculate torque about a point 1, 1, 1, whereas force acting on origin. So we have to find the torque of this force. 1 minute. Here the force is acting on this point P. Simple. He is asking torque of the force about origin. So about origin we have to calculate. This is the point P. About point P force is acting. What we will do is from O to this point we will go for position vector R bar. Then the torque acting on the point will be R cross F. So here R cross F, I mean it is a cross product. So from matrix method, I and J and K, R cap is from origin to point P. Origin coordinates are 0, 0, 0 and point P coordinates are 1, 1, 1. So position vector is 1 minus 0, 1i plus 1j plus 1k. So R bar is 1i plus 1j plus 1k and force is 2i plus j plus 2k. So 2, 1, 2. If I take this cross product, we will get I cap into 2 minus 1, that is 1, minus j cap into 2 minus 2, 0, plus k cap into 1 minus 2 minus 1. That is I minus k cap is the torque acting on the point. So about origin, the torque due to the point is I cap minus k cap. A simple answer for this question. Let us go to next one. In this question, electron is moving in a magnetic field in a circular orbit. So when it is moving in a circular orbit, radius of the electron will be mv over eb. And assume Bohr's quantization condition to be valid. The Bohr's second postulate is angular momentum of electron is nh over 2 pi. And here we have to calculate radius of orbit in first excited state. In ground state, principal quantum number is 1. In first excited state, n is equals to 2. So we can write mvr is equals to n is 2. So 2h over 2 pi and 2 cancel. So mv is equals to 2h over, so okay, 2 cancel. So no need to write 2 once again. So it is h over pi into r. Let us substitute this mv in this expression for radius. So radius r is equals to 1 by eb multiplied by mv is h by pi r. Shift r to left hand side, r square is h by pi eb, then radius will be under square root of h by pi eb. So this will be the answer. Let us go to the next question. It is also very simple. The displacement of a particle moving under the action of a force. The given force and displacement is said work done is 0. So in this problem, the force given is F bar is equal to 2I plus dj cap plus k cap. Whereas displacement given as S bar is equals to I plus j plus k. And he said that work done by this force is 0. Then what will be the value of D? We know that work done by the force is scalar product of force and displacement. So work done is 0. Scalar product is ax bx plus ay by plus az bz. According to that, 2 into 1 plus b into 1 plus k is 1 multiplied by 1. So 2 plus 1, 3 plus b is 0. Hence we get b is equal to minus 3. So this is about the question. Let me go to next one. The next one is from electromagnetic waves, from displacement current. We know that displacement current is depending on the rate of change of electric flux, that is epsilon naught into charge inside it, and according to dimensions it will change this. So here Nana, the charge from electric field between two plates of a capacitor, we can write electric field as sigma by epsilon naught. So q by a epsilon naught. So I can write charge as electric field epsilon naught multiplied by a. From this expression, we can say that the displacement current is directly proportional to area of the space in the space between two plates of capacitor. In the question is given that there is a parallel plate capacitor and area of each plate is 6 centimeters square and a current of 5 amperes is passing through the plate. In this, the region lying between two plates of the capacitor is asking displacement current through a portion of area only 3.2 centimeters square. So from this relation, displacement current is directly proportional to area. We can say that here if the total current is 5 ampere, that is equal to a constant multiplied by total area of the capacitor plate, that is 6 centimeters square. Whereas the displacement current through the region is constant multiplied by the area 3.2 centimeters square. So displacement current over 5 is equals to 3.2 over 6. And if you remove decimal point here 10, then 6. Here we can go for this as 2 3s and 2 16s are 32 and 2 5s are 10, 2 8s are 16, 1 5 we can cancel. So I'll get displacement current as 8 over 3 ampere. It is also an easy problem. Now let me go to the next one. In the next question, it is given that a proton is moving with uniform velocity 2 into 10 power 8 meters per second. So velocity of the proton is 2 into 10 power 8 meters per second in uniform magnetic field. There is uniform magnetic and electric field. They are perpendicular to each other. So that means this proton is going with constant velocity, both magnitude constant, direction constant. This can be possible either magnetic field is inside, which will apply force on proton q v cross b in upward direction, and a vertically down electric field will apply force in down. If net force is 0, then it will go with constant velocity. Now what he done is, he switched off the electric field. When electric field is switched on off, only magnetic field is existing, then it will travel in a circular path of radius r is equal to mv by qb, because here velocity of the proton is perpendicular to magnetic field. And in the question he asked the same thing. When electric field is switched off, the radius of the path followed by the protons orbit is given r. He is asking about magnetic field. So from this expression, magnetic field is mv over charge of proton e and radius. He given mass, velocity, charge of proton and radius. You can substitute the values and you can easily go for the calculation. Let us go to the next one. And here in the next circuit, it is a CR circuit. In the CR circuit, he given it as a battery of potential difference 2 volts, and this is connected with a wire of resistance R. Next, another wire of resistance R. Diagonally, one more wire is connected with a resistance R, and next a wire of resistance R is connected to a capacitor of capacitance 2 microfarad, and this is connected to another resistor, and one more diagonally resistor R. These are all connected to battery. So the question is, find the current in the circuit at steady state given that R is equal to 2 ohms. So every resistance is 2 ohms. We have to calculate current in steady state. During steady state, capacitor is fully charged. Hence the loop in which capacitor exists, no current travels. So in this portion, no current travels. Now between A and B, if you check, these two wires are in parallel combination. Then their equivalent resistance will be R1 R2 over R1 plus R2, that is R square by 2R. It will equivalent resistance is R by 2. So I replace these two with R by 2, and remaining you see R and this total, they are one after the other in series combination. You can see the circuit like this: 2 volts battery, and here is a wire of resistance R connected to A, and A to B, the equivalent resistance of the combination is R by 2, and one more wire from A to B diagonally is R, and these two are connected to battery. So R and R by 2, they are connected in series combination. So equivalent resistance is R plus R by 2, 3R by 2. 3R by 2 connected between C and D. Same, this R is also connected between C and D. So 3R by 2 and R are in parallel combination. When 3R by 2 and R are in parallel combination, equivalent resistance is R1 R2 over R1 plus R2. So 3R by 2 into R divided by 3R by 2 plus R. We will get this as 3R square by 2, and this is 5R by 2. Here 2 we can cancel, 1 R we can cancel. Equivalent is 3R by 5. In the problem it given that R is 2 ohms. So 3 into 2 by 5, that is 6 by 5 ohms is equivalent resistance. And potential difference is 2 volts. From the concept of total potential difference equal to current into equivalent resistance, 2 volts equal to current through the battery multiplied by equivalent resistance is 6 by 5. So current is, here you can replace 2 with 6. So this is 5 by 3 ampere. A simple answer for this. Let me go to next one. In the next question, it is related to an electric dipole. He said that the point capital A is situated on the axis of dipole at a distance small r from the dipole with the electric field E0 and electric potential V0. So if there is an electric dipole with minus q here, a smallest electric dipole, plus q here, and this is the center of the dipole. On the axis of the dipole from center at a distance r, the electric field is E0 and electric potential is V0. Here electric field on the axial line of dipole at any point electric field is, we can say that P into root of 1 plus 3 cosine theta square. P is electric dipole over R cube. Here theta is the line joining the axial line of the dipole to point P, where we have to calculate the electric field. In this case, line joining axial line to point where we calculate electric field from center is, both are coinciding. So theta 0, cosine 0 1, under root 4 is 2. Here 1 by 4 pi epsilon naught is the constant. So electric field is 2p over 4 pi epsilon naught r cube. This is the electric field on axial line at a distance r. He given it as E naught. What? This is given. And what is he asking? He is asking electric field on equatorial line of dipole, minus q and plus q. And if this is the equatorial line, along equatorial line at a distance 2r, he is asking. In this case, at equatorial line, theta is 90 degrees. So at equatorial line, the electric field will be 1 over 4 pi epsilon naught and P multiplied by root of 1 plus 3 cosine theta square. Cosine 90 is 0. So cosine theta square is 0. R cube, here the distance is 2r whole cube. So this electric field we can write P by 4 pi epsilon naught R cube multiplied by 1 by 2 cube is 1 by 8. You see from the earlier condition, here P 2p by 4 pi epsilon naught r cube is E naught. So P by 4 pi epsilon naught r cube is E naught by 2. So I replace P by 4 pi epsilon naught r cube with E naught by 2. So this is E naught by 2 multiplied by 1 over 8. We are getting this as E naught by 16. So this is the first option for this problem. And let me go to the remaining is given. One more is asking about potential also. About potential, whatever he is asking is same in the case of the dipole on the axial line at a distance r from center of dipole. He given that the potential is V naught. And what will be the potential at the same case on equatorial line at a distance r, distance 2r. On equatorial line, theta 90 degrees. And the electric potential depends on P cos theta over 4 pi epsilon naught r square. Theta 90 degrees, cosine 90 0. So potential 0. So on the equatorial line, the electric field is E naught over, as we did earlier, E naught over 16, and potential is 0. So E naught over 16 is electric field and potential is 0. We given this in first option. So that's about the problem. Little bit lengthy, but it is also a simple and easy problem. Let me go to the next one. This is from wave optics. In this is given that assertion and reason statements. Here in Young's double slit experiment, he said that the YDSE setup for red fringes are wider comparing with blue. Here the width between any two bright fringes or any two dark fringes is beta. If beta is more, fringes will be wide. Beta is less, fringes will be very narrow. And this beta depends on distance from screen to slits D, wavelength lambda, slit width A. So beta directly proportional to lambda. Wavelength for red color light is more than the wavelength for blue color. So fringe width for red color will be more than fringe width for blue color. So the assertion is correct. I read assertion once again. In YDSE setup, red fringes are wider compared to blue one. Red fringes fringe width is more, so they are wider comparing with blue one. And the reason is fringe width is directly proportional to wavelength. So it is also a correct statement. That's why assertion is correct and reason is also correct reason for it. Let me go to next one. This next question is from electric capacitance and the units and dimensions. Find the correct dimensional formula for capacitance in terms of M, L, T and C. Here M is the unit of mass, L is the unit of length, T is the unit of time, C is the unit of electric charge. Then what we have to write? We have to write dimensional formula for capacitance. We know that capacitance has charge over potential difference. And potential difference we can write work done to move one unit charge from A to B. That is work done over charge. So if I replace charge to numerator, this is Q square divided by work done. Q should be replaced with C, so C square, and work done dimension formula is force into displacement, that is ML2 T minus 2. So the dimensions of electrical capacitance is M minus 1, L minus 2, T square and C square. So this is the dimension formula for capacitance. So that's about the question. Let us go for next one. And in this question, he is asking about in a series LCR circuit. Here a series LCR circuit, a coil of self-inductance L, capacitor C, resistance R, when they are connected to AC power supply of EMF amplitude E0 and frequency some omega. He said the maximum amplitude of current is I0 when resistance is R. Here current amplitude I0 will be maximum when impedance is very minimum, and minimum impedance of the circuit is R, because this is happens at resonance. At resonance we know L omega naught equals to 1 by omega naught C. So they balance and impedance will be R. And in the second case he is asking about what is the maximum amplitude of current if the resistance is replaced by a resistor of resistance R by 2. Only he is replacing R with R by 2, source is same. So in the second case, current amplitude maximum value is same EMF amplitude. In the place of R, he replaced with R by 2. That is 2 times to E0 by R. That is 2 times to initial value. So answer is 2I0 in second case. And that's about that problem. Let us go to next one. Next one, he asked about the logic gates in semiconductor devices. It is also a direct question. In this case, A is connected to a PN diode and B is connected to another PN diode, and these two are connected, and at this junction Y he is taking output potential, and this Y is connected to a wire of resistance R to a battery of potential difference 5 volts, and these two earth, and here is A and B. Naturally this is the circuit of an AND gate, so that only given, which name the logic gate R and not and NAND. It's a circuit of basically AND gate, completely theoretically based question. So let us go to next one. In the next question, this is related to the electromagnetic induction. A uniform magnetic field is existing in this region. So magnetic field is existing in this region, and a conducting circular ring enters into the region with a velocity v. Then identify the correct graph between induced EMF and time. So we have to calculate how the induced EMF varies. See, in this condition, when gradually it is entering into the magnetic field, gradually the effective length of this conducting region when it is entering into magnetic field is increasing. So here the EMF is equals to the velocity of the connecting region B multiplied by length of the region. So length of the region is increasing, gradually increases, and when center portion is passing through the starting point of magnetic field, EMF maximum, Latter equivalent length is decreasing, EMF decreases, and when it is coming out, then EMF direction will be in opposite direction. So in opposite direction, it is given in the first option in the question, a directly theoretical question. Let us go to next one. In the next question, it is related to the viscosity, that is properties of liquids. A body of mass m. So this is a body of mass m dropped in glycerin in a certain medium until it achieves a constant velocity. So when it is completely dropped in glycerin liquid while going down, here when it attains a constant velocity, here at this instant what will be the viscosity force acting on the drop? That is a question. And given that density of the glycerin liquid is equal to half of the density of the body. Here density of the liquid is given as half of the density of the body. So when the body is moving in the liquid, then let me go for the forces acting on it. One is gravitational force mg, and next is buoyancy force and viscosity force. Let us imagine viscosity force is F, then buoyancy force will be volume of the body into density of the liquid multiplied by G. Here he given that the density of the liquid is density of the body divided by 2. Then volume of the body multiplied by density of liquid is volume of the body multiplied by density of body by 2. Density and volume is mass. So mass of the body by 2. Hence this term is m by 2. Hence buoyancy force is mg by 2. Now when it attains constant velocity, then acceleration will be 0. So according to Newton's second law, if I take upward direction positive, then the viscosity force F plus buoyancy force mg by 2 minus gravitational force mg, net force acting on it is 0 because it is going now with constant velocity. Then viscosity force will be mg minus mg by 2, so it is mg by 2. So this is the answer for this question. And let me go to next one. Let us go to a next question. It is again from photoelectric effect we are getting. Here a photon of wavelength lambda, when it falls on a metal plate having work function 1 electron volts, maximum kinetic energy of emitted electron is 2 electron volts. The Einstein photoelectric effect equation is Hc by lambda minus work function equals to the maximum kinetic energy of emitted electron. When the instant photon wavelength is lambda and the given work function for the material is 1 electron volt and maximum kinetic energy is 2 electron volts, so we will get the Hc by lambda value is 2 plus 1, that is 3 electron volts. Now in the second case, on the same material, photon of wavelength lambda by 2 is allowing to form. So the instant photon wavelength is lambda by 2. Work function is same 1 electron volt. Then what will be the maximum kinetic energy? Here this we can write 2 times 2 Hc by lambda, that is 2 times 2 3 minus 1. This is the maximum kinetic energy. Nothing but 6 minus 1 5 electron volts. Now let us go to the next one. In the next one, he is saying that a particle is moving in a vertical circle. Radius of the vertical circle is capital R, and find the ratio of kinetic energies at point B and C. Here if this is the vertical line, point B is here at an angle of 60 degrees and point C is here at an angle further 60 degrees. And what about the radius given? Here find the ratio of kinetic energy at point B and C. Okay, that's about. and given in the diagram as radius equals to 2 meter. Here initially when it is at the bottommost point given in the question, the velocity is 20 meters per second. When it is moving in vertical circular path, because only gravitational force is acting, if I imagine here velocity v1 and here velocity v2, then total energy will be conserved. That is kinetic and potential energy will be conserved. So let me apply the conservation of energy. Let us imagine this is A and given as B and C. If at A I imagine potential energy is 0, then at A potential energy is 0, kinetic energy is half m v naught square, and that is equal to at B. Here the total radius is 2 meter. So from center to this A the total is 2 meter and this is 2 meter. Then 2 cos 60, that is 2 into 1 by 2, this is 1 meter. From total 2 meter, if I remove 1 meter, so this is again 1 meter. That is at B, it is from ground at a height of 1 meter. So potential energy at B will be mg multiplied by height 1 meter and kinetic energy will be half mv1 square. And from this, here V naught is given as 2 meters per second. In the question, here mass is not given. So half m V naught is given and you can take approximately G as 10. So this is V naught given as 20 meters per second. So 20 square, that is 400 by 2. So this is 200 times 2m. And G, if I take it as approximately 10m, this is equal to this plus half m v1 square. So 10m plus half m v1 square. From this, half m v1 square is 200m minus 10m, that is 190m. So half m v1 square is 190 times 2 mass. This is the kinetic energy at point B. He is asking about ratio of kinetic energies only. So I don't want to disturb m there. Let us keep it as it is. When it will go to C, here the total angle here to here 60, here to here to 60. So 120. Then this angle will be here 60 degrees because total one side angle will be 180 degrees. So this is 60, then R is 2 meter, then this side above the center will be 2 cos 60, again 1 meter. So 1, 2, 3. Now at C it is at 3 meters height. So at 3 meters height, again if I consider the total energy between A and C, at A total energy as we discussed half m V naught square, V naught is 20, 20 square is 400 by 2, 200 m. So initial kinetic energy 200 m, we are taking at A potential energy 0 is equal to, at C potential energy is mg into 3 meter. So mg multiplied by 3 meter plus kinetic energy half m v2 square. And here this is, if I take G approximately 10, 30 m, 200 minus 30 is 170. So 170 m is kinetic energy at point C. And the question is, find the ratio of kinetic energy at B and C. So find the ratio of kinetic energy at B and kinetic energy at C. Kinetic energy at B as we calculated is 190 m and at C is 170 m. So 190 times 2 mass over 170 times 2 mass, that is 19 over 17. This will be the answer. Let us go to the next question there. Here in this question it is related to elasticity and rotational dynamics. A uniform straight rod is given and mass of the rod is 2m, and this is an axis passing through one end of the rod vertically, It is rotating around this axis with angular velocity. Given that this angular velocity is root over f divided by alpha times 2m. Question is find alpha. And that one more information is given is tension in the rod at end A is capital F and length of the rod is 1 meter. And this rod is AB. Here the centripetal force acting on the rod is if I take the tension acting on the rod at A as F, the net force acting on the rod here is F. After B no material, so no tension. So net force F is equal to total mass of the rod 2m multiplied by acceleration of center of the rod. Here center will follow a circle of radius 1 by 2. So mr omega square, r is 1 by 2 multiplied by omega square. And from this 2 gets cancelled. Then F equals to m omega square. Omega is under root F by m. Comparing this with the given data, we can say that alpha is equal to 1. So this is the answer for this question. Let me go to next one. This is from errors and measurements, an integer. He is given that mass of an object is m is equal to 0.60, means up to second decimal point it was measured, plus or minus 0.003 grams. And radius of the I think the object is like a cylinder. Radius of the object is 0.5 and plus or minus 0.001 centimeter. And length of the cylinder given as 10.00 plus or minus 0.05 centimeter. Question is find the percentage error in the measurement of density of the wire. So the wire may be in solid cylindrical shape. Then for a cylindrical shaped wire, density is mass over volume. Volume is area of cross section pi r square and length L. Pi is a constant. So as we know, we can calculate it as delta rho by rho equals to delta m by m. R square is there. So maximum error is always positive. We are taking 2 delta r by r plus delta L by L. Though it is in denominator or in numerator, we will take the maximum possible error. So for all terms, we will give positive sign. And percentage increase in density means delta rho by rho multiplied by 100. So here we should multiply every term with 100. So let me use this condition. Here according to that, the percentage increase in density delta rho by rho into 100 is equals to, here delta m is given as 0.003 divided by m is 0.6 delta m by m into 100. Percentage error in mass and percentage error in radius 2 times to delta r by r. So delta r is 0.01 by radius is 0.5 delta r by r into 100 percentage in radius, and percentage in length is delta L by L. Error in length is 0.05 centimeter, length is 10 centimeter and multiplied by 100. From this, here this will become 0.003 into 100 is 0.3 by 0.6, that is 1 over 2, plus here this will become 100 into 0.01 is 1, that is 2 by 0.5, that is 20 by 5, 5 4s are 24, and this is 0.05, 1 0 we can cancel, 10 into 0.05 is 0.5, again 1 by 2, so totally half plus half is 1 plus 4 5, so 5% is the percentage error in density. That's our the problem. And one more small problem is given in from kinetic energy relation and projectiles. In this case, he said that a ball of mass 100 grams So when mass is 100 grams, I mean in kgs it will be 100 by 1000, that is 0.1 kg. And it is projected from origin with an initial velocity u is equals to 20 meters per second at an angle of theta is equal to 60 degrees with horizontal. The question is, we have to calculate change in kinetic energy from point of projection of ball to the point when it reaches maximum height. So when it reaches maximum height, mass remains same, velocity y component becomes 0, only x component exists, that is u cos theta, that is 20 multiplied by cosine 60, 10 meters per second. So change in kinetic energy is initial kinetic energy half m into velocity u square minus kinetic energy at maximum height is half m into u cos theta square, so u square cosine square theta. Half m u square we can take it as common, and this is 1 minus cosine square theta, and 1 minus cosine square theta is sine square theta. So this will become half m u square sine square theta, and half as it is, mass is 0.1 and u is 20, 20 square is 400 and sine 60 is root 3 by 2. So sine square 60 is 3 by 4. Then we will get it as 4. This is 100 times 100 into 0.1 is 10, and 10 here 2, here 50 into 0.1 is 5, 5 3s are 15. So totally 15 joules. Just check the simplification. I will get in short. Okay, this is about the question paper. Thank you.